Okay, so I'll give a quick background on where we're at. As of last week, we were discussing writing our own sample driver, and we discussed that our sample driver will be a very simple in-memory driver that simulates bucket creation and bucket access creation. Um, Ideally, you'll just maintain a simple map or some data structure in memory that just says there's a bucket by this name. Um, it is not meant for supporting any data APIs, IO APIs, like putting data into it or reading from it. It's just meant to simulate the provisioning side of things. Nicholas has been working on it, and he has an update to share with us. So let's start with that. Um, Shinga, okay, we're recording.
Yeah, so I'll
Yeah,
try to
recording.
share my screen. Oh,
I think you might need permission for that. Shing, can we? Okay, there.
okay. Wait, what? Maybe like this. Do you see like a browser?
We see a background.
Oh, damn it. Do you see a browser now?
No, I don't. Okay, now I see it. Yes.
Oh,
Yeah.
so now you see one?
Yeah, I see browser. Oh, went away.
Huh?
All right,
Like
hold on.
this?
Yes, I see it.
Okay. So, as Sid mentioned, indeed, after the conversation last week, I went ahead and implemented this sample driver.
Hey,
Currently,
sorry to cut in. I don't know if it's just me, but the browser went away again. Maybe
Yeah,
others can.
I only see the I only see your background now.
okay, so this better? Sorry, I'm not used to Zoom.
No. Okay, yeah, now it shows up again.
Mm-hmm.
Okay, so I put it on my second screen. Maybe it sticks around now.
Mm-hmm.
Just let me know when it goes away. So I implemented this in a private repository. Well, I mean, not the Kubernetes SIG, not Kubernetes SIG repository yet. I think the intent is to move it there. What I did was indeed implement the whole gRPC API, and then also added a bunch of things which drivers that are not necessarily within the Kubernetes organization may want to have as well when it comes to CI, etc. Of course, all of that is opinionated. Others may want to do CI differently, which is fine. It's just a couple of examples. Code-wise, it's really not that much. And maybe just going through it, I can first show like the Docker file is a very simple Docker file which performs a build in which you can run the unit tests and which performs the actual build of the file container. So there's two containers, one in which the binary is built, one which is what you actually ship into a Kubernetes cluster. Other than that, there's not much in the root. Code-wise, I split it up in one, the command, so the main entry point for the provisioner, and two packages, which are kind of reusable code, whether this is not public API right now, so whether we see these as something other provisioners can build upon is to be seen. When it comes to the command, so this is basically what you want to implement as a provisioner, a vendor who wants to have a provisioner for a storage system. The main entry point is really fairly simple. Provisioner name obviously needs to change, and the Go import path, etc., needs to change as well. I just made everything for this repo. All you can provide right now is an endpoint, which is where the provisioner will listen, as in a Unix. So the provisioner itself is a gRPC server. So the endpoint is the Unix domain socket path you want to use, or a TCP socket, like an IP address and a port number that you want to use. I was thinking of building a a small CLI utility as part of this as well, which allows you to invoke or easily invoke from the CLI RPC calls on a Cozy Provisioner gRPC endpoint for purely for testing purposes.
So there is, yeah. So we can talk about that. There's something called gRPC curl which we can use for that kind of testing, which
Okay.
is quite interesting. In the meantime, I have a few questions about this though. So how is this? How does it create buckets? Does it use like an in-memory data structure of some sort?
Yeah, so let me first, in this file, all I do is parsing of the command line arguments. Then the provisioner server is what you actually need to implement as a storage system author. We have two servers in the Cozy spec. There is the identity server and the provisioner server. The
Okay.
identity server, I simplified a bit, and then I can go through that in just a minute. Where you don't really need to implement the identity server yourself. I build a wrapper which basically just takes a string and gives you an identity server as a result. And then there's a bit of code to, well, basically set up all the whole gRPC server, set up signal handling and whatnot, which is likely shareable between multiple provisioners. But again, this is up to you whether or not you want to do so.
Right.
Then on the actual provisioner server, so this is where the provisioner server gRPC interface is implemented. And indeed, it's super simple. This one is purely in memory. So if you restart the pod in which the provisioner is running, then everything's gone. It doesn't really try to remember anything, which would complicate things a bit. The data model, as I just put on Slack as well, is slightly weird because I keep access credentials that are requested to that are created to access a bucket within that bucket. I don't keep the accounts so you want at the storage system level. May want to change that, but functionally this works. It just doesn't necessarily map easily to a real storage system.
Yeah, that makes sense.
So I have buckets, and a bucket has an ID, which I chose to be a UUID for simplicity's sake. But of course, that depends on the backend storage system. A bucket has a name, and a bucket may have had a bunch of parameters passed in at creation time. And we need to keep those around to ensure one of the idempotent guarantees that the Cozy spec requires. And then within a bucket, I keep the accounts that are created for that bucket around as well behind a read-write mutex, both in lookup by name as well as lookup by UUID, because you kind of need both to implement the RPC calls. And an account itself, it's got an ID, it's got a name, it's got an access policy, but this thing doesn't implement any kind of access policy because it's not providing any actual storage. So I just keep that around. And then similar, the parameters that were passed in when the account was kind of created are kept as well, again, to make sure that we can implement one of the calls that require idempotent correctly.
I see.
My provisioner server itself, it's a struct in which you can keep, for example, a client to your storage systems API, if that's applicable. In this case, I just need to keep a mapping of buckets, either by their name or by their ID, UUID, to the bucket instance, again, that map behind the read-write mutex. And I make this struct inherit. I know it's not the right word in Go speech.
Embed.
The unimplemented provisioner server, such that, and of course, at this point in time, maybe I shouldn't do so. But if at some point we have the 1.0 release of the Cozy gRPC spec, then any provisioner could inherit from the unimplemented one, such that any new calls that are added post 1.0 to the gRPC spec should be optional calls, otherwise we're breaking backwards compatibility. And using this approach, any provisioner,
Actually, hold on. Yeah, so don't you think it's better if we actually failed, if the calls were not implemented rather than succeed or fail silently. Um,
It's
because
not really
adding
failing
new calls,
silently.
so adding new calls, it doesn't break backward compatibility. Removing old calls breaks backward compatibility.
Yes.
So in this case, I mean, I like the idea of having this unimplemented provisioner server, but in terms of guidelines, I wouldn't say just because you have this unimplemented interface. I'm guessing it's an interface. I don't see it here. Um, just because you have this unimplemented interface, um, does not mean like your provisioner is actually API compliant. It'll compile with whatever new dependencies we bring in. However, like I see why you've put it there, because it's a great way to have the compiler type check if the provisioner server implements all the different APIs.
No, that's line 54. That is a type check.
Mm-hmm. Yeah, that's what
The,
I'm saying. Yeah. Huh?
so
Yeah.
this spec itself is from the container object storage interface spec, and then implemented provisioner server is a struct provided by the protobuffer or the gRPC compiler, and it's basically a struct which implements all the calls that provisioner server has and makes them
Oh,
return
it's
an
already
error
in the
saying
gRPC.
unimplemented.
Got it. Yeah, that was going to be my real question. Really, that is, shouldn't we put this in the central gRPC server somewhere? If it's already there, this is great.
Yeah, it's for every proto file to gRPC compilation you do in Go, you get an unimplemented foo server
Service.
with it.
Yeah. Cool. All right. Keep going forward.
So then on line 54, there's a fairly standard type check, just making sure that I actually implement spec.provisioner provisioner server, which is always the case because indeed I inherit from an unimplemented provisioner server. You can create a new one, which sets up those maps, those in-memory maps. And then there's the implementation of the various calls. So in create bucket, I only support S3 buckets. Of course, this is very arbitrary because I don't actually support any of them. One thing I noticed while implementing this is that unlike in the CSI spec, which errors are supposed to be returned is not specified in the COSI spec. In this case, like if I only support S3 and the create bucket request requests an Azure blob bucket, then returning invalid argument, I think makes most sense given the set of standardized error codes, but we may want to make that more explicit in the spec.
Yeah, the error code here makes a lot of sense. Um, yeah, we need help, Nicholas, to fill out these things. I would
Yeah.
really appreciate it if you would, look into it and maybe even make a docs PR
Yeah.
with the right error codes. That would be really good.
So then in the implementation, I do a fastpot check whether the bucket already exists. If it doesn't exist, I need to create it and add it in the tool lookup maps. I then validate whether the parameters that are passed into the create bucket request are the same as the parameters through which the bucket was created before. If that is not the case, and according to the spec, you have to raise an alert exists or return an alert already exists, error, which is what I do below. And if everything is fine, so either it already existed with those parameters or it now has been created with those parameters, then I simply return a provisioner create bucket response with the bucket ID being the ID that I just gave to that bucket, the UUID.
So a few things here. It
Yep.
seems like we're mapping accounts to buckets on the bucket side, whereas in the API, the accounts are mapped to the buckets. The accounts and buckets are entirely independent components, and the mapping is taken care of by COSI. Why is there? So is there any particular reason we've done it this way here?
So as I said before, the strange thing here is that indeed I keep accounts inside a bucket. So the I don't keep them global at the storage systems level. I was not aware that within COSI, one account for a given account name can be requested access to multiple buckets. Again,
Yeah,
it doesn't really change much, because even if that is the case, this code will still work, but it doesn't really map to how a real world storage system would be designed, most likely, where indeed you have two top level entities, one being accounts, one being buckets, and then there are links between those two when a particular account has given a particular policy access to a particular bucket.
so okay, so one is being like having it uh, represent the represent an the how the storage system looks in general would you know would probably make things easier, but I see what you mean here. In this case, I don't have a specific reason why this wouldn't work. That being said, so you were saying, so let me think about this. So you're saying that um, here, yeah, this is the thing I want to bring up. So you're saying that one account can actually be used by multiple buckets. Um, I don't think that's possible because the way we've modeled it is we always create a new account, or we send a new provisioner grant bucket access
Yep.
each time we ask for a new bucket, and the account name that we pass through there is a unique UUID,
Yep.
which would mean, I mean, I'm sure there is a way we can have the same account used for multiple different credentials, but that is very unlikely. I
So
mean, that's an anti-pattern basically.
the way the Cozy gRPC spec is designed,
Mm-hmm.
because I built this like piecemeal, step by step.
Mm-hmm.
That one got me to put these accounts within a bucket, and it's only later that I realized that that doesn't it fits perfectly in Cozy, as in it works, and there's no real reason why this model would be incorrect. But then again, it doesn't map to how most storage systems most likely work.
No, I don't understand. Like, what do you mean by that? For instance, um, are you saying that the way you've implemented it here doesn't map to how storage systems work, or do you mean the way where we've kept accounts and buckets as separate entities is not the general way in which they're implemented?
No, I think the way Cozy models things
Mm-hmm.
is correct. The
Mm-hmm.
way the calls are made, the fact that a new account is being requested for every bucket access
Mm-hmm.
makes sense.
Mm-hmm.
But and then here I can only talk for the Scality implementation because I don't know how other storage systems work internally. But we
Mm-hmm.
keep not two databases, but two tables. So you want is not really the case. Where in one we track accounts, and in another one we track buckets.
Mm-hmm.
So it's not that the account. It's not that if you delete the bucket, that all the accounts would be that had access to that bucket would be deleted with it. Whilst in this current prototype, this current sample, that would be the case.
Oh, I see what you're saying. So you're
But if
saying
you
if
look at line 41 and 42, my bucket is my high level object. And within a bucket, I keep the accounts that have access to that bucket, which is a bit weird, but it fits perfectly with Cozy.
Well, actually, it doesn't, right? Because there are use cases where we delete the bucket first. Like, let's say, you have the deletion policy set to force, and someone's supposed to go and clean up the accesses after. How that use case would not be represented by this data structure.
But the strange thing then is, if I'm not mistaken, let me scroll down. Just this is then grant bucket access where I do a couple of pre-checks or sorry, check whether the account already exists. If not, create it and do a couple of checks whether the parameters match and the access policy match.
Mm-hmm.
And delete is the same, but I believe within delete you pass in the bucket ID. So that would mean that we can receive a provisional revoke bucket access RPC, which contains in the request a bucket ID of a bucket that was already deleted before, for which a delete bucket was invoked before.
Okay, so what happens there?
No, it's a question because the
Yeah,
scenario you just explained is
yeah.
we don't really have a segregation between buckets and accounts because even revoke bucket access has a bucket ID and an account ID in it.
Yeah, so yeah, if the bucket is already gone during revoke, how does that work?
I don't know.
No, how does it
I'm a
work here?
provisioner. I can't really say how I will be called.
No, I'm saying, let me put it differently. So, um, assume that bucket is already gone and provisional revoke bucket access gets called. So, um, in that case, you would try to delete request.bucket ID. Oh, so you're saying bucket ID has to come from somewhere. Yeah, we can give you the bucket ID. So then what do? You then parse account ID from there. Okay, that also we can give you. Um, and what
No,
happens?
I first check the bucket. I parse the bucket ID and then I check whether the bucket exists. And if it doesn't, then I say not found.
Okay, so that is not true, right? Because the bucket is not found, not the account is not found.
No, the bucket could be not found if bucket ID is no longer available in my buckets by UUID, then it means that delete bucket was already called because that's the only place where it gets removed.
Yeah, I'm saying it doesn't model the cozy API right now then, because you can have a situation where revoke is called after delete is. I mean, like in Kubernetes, you should always account for that. Order of operations does not matter, should not matter, and it should be idempotent. That means you should return success because it's already gone. Um, would it help if you modeled the account as a separate data structure? I don't
Like,
imagine it's a lot of work.
no, it's not a lot of work.
Okay.
It's really easy. But then my question is, um, then revoke bucket access. That means revoke access for the given account ID
Mm-hmm.
to the given bucket ID.
Mm-hmm.
But how do we then have, delete the account?
So so okay. So I think I see where you're coming from. So you're saying we're just taking one account, and for that account, we could have multiple different accesses, but we're removing this specific access. That's what we're saying. That's what you're saying, right? So if that's the case, when does the account get deleted, right?
Yep.
Yeah. So I think maybe the word revoke bucket access is what's confusing here, because when we use the word revoke or use the phrase revoke bucket access, what you're really saying is revoke access for that bucket. But what we should say is, or between us in conversation, and I don't know if we should actually change the name of this call, because so it's pretty common pattern. But what it really means is remove that account. Associated with for accessing that bucket. So and it comes from the fact that whenever we grant bucket access, we create a new account. So uh, so when we grant access to the bucket, what we do is we actually go and create a new account that has access to this bucket. So
Yep.
that's where the word grant bucket access comes from. And um, revoke actually deletes that whole account, and by deleting the account, you also remove the access to that bucket.
Yes. But given this account is this account only has access to one bucket, right?
Yeah,
So
that's the idea. That is, one account will have it's a one-to-one mapping.
yes. Which means that if you delete the bucket,
Hmm.
then within the storage system, all the accounts could be deleted as well because they're of literally no use anymore.
Well, that's one way in which storage system is modeled, right? We don't know that for sure, and in most storage systems, that's not the case actually, because
Agreed.
yeah. So should we also model it according to other storage systems? Is my question.
Well, again, I don't know, but now in the case of revoke bucket access, if
Hmm.
we say that accounts are separate from buckets,
Hmm.
and it just happens that for every bucket access, we create a new account,
Hmm.
and we say give access to this bucket, and then the account gets returned, so you want,
Mm-hmm.
then is there a reason we pass in the bucket ID in the revoke bucket access request?
Mm-hmm. Um,
But it should be useless information at that point.
well, you again, we can't say that because, um, um, for instance, the account ID could be, um, you know, um, so let me think about this. I see where you're coming from. That is, if if the account ID itself is a unique ID, why would you need the bucket ID to uniquely identify the account?
Exactly, because then the
So,
accounts are up next to buckets, a top level object.
right. There was a good reason for it. I'm just trying to remember. Yeah. So the reason for it is, uh, let's actually go back and look at the API. Maybe the reason for it is likely just that we haven't removed it from the API, to be honest. If you can open Kubernetes SIGs slash container object storage interface spec, we can go and take a look at it again.
You mean the spec proto or spec MD?
The proto, the other one. Yeah, no, not the one. Next one.
Sorry?
Yeah. This is good. So I think there's some lag.
Oh.
All right. So let's see. Grant bucket access request, grant bucket access request, and revoke bucket access request. Account ID, and yeah, bucket ID is here. So let's talk about this. So if bucket ID is if account ID is the globally unique identifier, and is that what we say in the grant bucket access response? So will be required later to revoke access. Um, yeah, I think I mean, if the assumption that account ID is um, globally unique, then we shouldn't ideally need bucket ID.
Indeed.
Um, so however, okay, let's talk about this. This is something we can address. I want to address it with everyone in the group. But in the meantime, can we discuss uh, like, in a sense, can we actually implement the sample driver without this thing in holding us back? Because if you go to the sample driver now, I understand. So you're saying because the API is designed that way, you know, you're going and implementing your API the way you're implementing it, but that's actually wrong here, because what you're doing is you're not satisfying the API still. So what is happening here is, uh, because of the way this is modeled, we are not able to simulate the force delete use case. So I understand there's something that could be changed in the spec, but however, that shouldn't stop us from implementing this, right? Correct?
Yep. So I believe if in this implementation, I can remove a bit, no, basically change line 197, which now, if the bucket for the bucket ID that you pass in a revoke bucket access request no longer exists, then I say return provision revoke bucket access response nil.
So you're saying, yeah, so that would be yeah, so you're saying you'd return a nil error, yeah, the same as line 216.
Yes, indeed. Basically say that bucket doesn't exist, which means that that access doesn't exist because the access is kept within a bucket. So I'm good.
So you're saying that you don't have to create account as a separate concept.
Well, maybe I should, but even in the current data model, the intent of the API could be, I mean, I
So
think it should be
let
explicitly stated in the spec, but could be adhered to by just changing line 197 into, okay, I'm done.
So let me ask you this. So if we were to model it naturally the way it is, um, then issues like this that we just found will not happen. We wouldn't even have to. So what we're trying to do right now is coming up with a new model on top of how things existing, work exist right now. So what that requires is for us to deal with edge cases like this. A better abstraction would be to model the system exactly as the way it is expected to behave. When you do it that way, then these edge cases don't even exist, and maintaining this code will be much simpler. It's just good abstractions.
I agree,
What do you
but
think?
the way it's expected to behave is, I don't know where that is written right now. So there's nothing I can go by.
I am telling you.
Yeah,
Yeah,
I
so
didn't know. I didn't know a week ago.
um, the KEP actually clearly says it. The KEP has this information about how and also not just KEP, just through inference. There is no other way this could work other than having a new account created per request. um, and and this whole reverse mapping of because the bucket ID is there in the revoke access call, I have to model the API this way. That doesn't make much sense to me actually. So what I would suggest is we create account as a separate concept and
Yes. So
have that work there. Yeah.
I totally agree. At the
Mm-hmm.
same time,
Mm-hmm.
we should also work on extending the spec, not the cap, so that one can implement a provisioner by correctly and according to the expectations of the surrounding framework, implement the spec.
How so?
I got a question. So for Amazon S3, for instance, for the provisioner for Amazon S3, how would the account look like? The account ID.
It's an account ID. Account ID would be a universal resource number, a URN. It'll just be a string
But
that.
we're supposed to create, for instance, if we were to write the official COSI provisioner for Amazon, for instance, when we grant an access, are we supposed to do what? To create a user or an account or what?
A service account.
So a full account, like
Yeah.
so it's basically an entity. It's
Right.
an account can create sub-users and stuff. Are you aware of that?
So those are organizations. So
No, within an organization, you can create multiple accounts.
right. I'm
And
aware.
within an account, you can create multiple users.
So when you say account, is that equivalent of a project or is that equivalent of a user?
It's so for in the Amazon S3 world, an account is typically a tenant, right?
So we call it project and okay. So yeah, when I say account, I don't mean tenant, I mean user.
All right. So back in the day, companies had only one account for their entire organization, right?
Right.
And they would create tons of users and stuff. Now there is a new API which is called the organization API, and it allows organizations to create multiple accounts, but it's some kind of refinement. But historically, people had only one account for the entire organization, right? For the entire tenant, they had only one account and thousands of users, right? So when you're talking about when you're we talked about many times, ideally you're supposed to bind a role to the bucket and all, but for the V1 we cannot. So what do you expect? Us creating a user or us creating an account?
So account cannot be associated with the bucket. So account is more like a namespace. It's more, what do you mean by account? Is more like a namespace, which is a group of resources that are managed a particular way. Just because you create an account for a new bucket does not mean there's no credentials associated with that account that will just naturally give you access to that specific bucket. A user can be made to have access to that bucket, but not the entire account by itself. So
it's a user. So then you're thinking about using a user, right?
I mean, that's the only way it can work. Yes.
Okay, well, that's fine.
Yeah, and when I say service account, in AWS, service accounts are users that don't have access to the web console. That's what it is.
Okay, no, it's very clear. So we are supposed to create a unique a dynamic user, right? And this user will have what? A unique arm, right? It can be uniquely identified by what? What do you expect?
URN, yeah. In case of AWS, that would be the universal resource number.
Okay.
Yeah. Any UUID that's global to the storage system you're talking to is good for us.
So when you create when you grant the access, so when you create a bucket, this is at the account level, right? So nobody has access except the admin for the account, the root. Then you grant access to a bucket. Then you dynamically create a user. I'm talking about Amazon S3, right?
Right.
So you dynamically create a user. You dynamically provision a policy for the user to access the bucket, because by default the user has no access.
Right.
It's a service account, so it doesn't have any console access, so that's fine.
Right.
And you're supposed to return that. Now, when you revoke the access, what are you supposed to do? Delete the user or what?
Delete the user.
That's it.
That's it.
So that's very clear.
Yeah, it is.
Okay.
Yeah. Question. On a similar note, the account, or I mean the user, can be identified by an access key. If you look at Amazon, I mean, it really depends if we are looking at a user that can rotate keys or whatever, right? We discussed it quite a lot, but assuming we don't, which is what we ended up with, I guess, right? Then basically what we're provisioning here is credentials, is access, and that's it can also be identified like directly with an access key.
Right. So we just call it account ID in case you want to change it to, have a separate identifier, like a separate unique ID. But there's nothing that stops the driver from returning the access key itself as the unique ID.
So Nicolas, what is the confusion or the?
Yeah, the confusion is, so currently the way this project models the account is it is a sub resource of the bucket. So when the bucket is deleted, the account goes away naturally. So if you scroll up, Nicholas, you'll see that there is a data structure called bucket, and the bucket has a bunch of accounts in it. Nicholas, can you scroll up a little bit? Yeah. So line 35 is where bucket is defined, and 41 and 42 are the accounts that are held within the bucket. Now, when we delete a bucket, what happens is the bucket goes away, but then along with it, the account also goes away. There is a use case in Cozy where the bucket is deleted first, and then the account is cleaned up later. So this wouldn't be able to model that use case in a natural manner.
So if we were to write the Amazon S3 driver again, you could totally delete the bucket without deleting the users, right?
Right.
So you would still need to have the revoke user call.
Right.
So I'm happy to make those changes. Really, guys, let's not make a big deal out of it. It's a super simple change.
Yeah.
However, maybe we should then remove the bucket ID from the revoke bucket access request.
We can, yeah. I'm happy to bring this up with the group, and I want everyone to be here when we talk about it. Like, I don't think Ben is here right now. We have Guy and others too. We could start the discussion today, but I think removing a spec field, I would like to have a little bit more of a discussion before we make that decision. So that's all I have to say.
So in that case, is Cozy right now tracking the bucket ID in a in a BA as well?
It needs to know which bucket it is for. Yes, it does.
Okay, fine. Yeah.
So yeah, so in the meantime, maybe I think you can go ahead and implement it the right way, and because that decision should not affect the sample driver in any form.
Agreed. Yeah, I mean, it should be like 20 minutes of work at most.
Right. Yeah.
still going on and through the code. I added a couple of tests as well using Ginkgo and Gomega. I don't know whether you're familiar with it.
Yeah.
It's like a testing framework for Go. And these, or at least some of these, we may be able to again reuse across multiple provisioners, because it performs high level calls, and it's not over the gRPC. It directly calls into the API, the implementation. It's not going through gRPC socket, etc. I have tests for that elsewhere to ensure that, for example, idempotence is guaranteed. The fact that you can not overwrite an existing bucket if you call provision or create bucket with different parameters, in which case the spec says an already exists needs to be returned. So these are some really basic unit tests, functional, well, they're not functional unit tests, I guess, of that sample implementation of provisioner server. Really not that much about it.
Nice.
So that's kind of what you need to implement for a provisioner. And then I have under PKG, what I talked about before, the identity server is really simple. It's something that, given a string, gives you an identity server, such that it's really easy to implement identity server, rather than having a little bit of code duplication. But because I use this one, so it's got tests as well, of course, which is really simple. When I call provisioner get info, do I get the provisioner name that was passed into the new identity server? And then Cozy Provisioner is a bit of utilities to run an actual provisioner gRPC service. This one sets up a logger for the request responses, creates the server. You can start a server on Unix domain sockets or on TCP. You can stop a server, you can gracefully stop a server, you can wait for the server thread, well, Go routine to return. It's using klog for the actual logging. And then run is a bit of wrappers to set up signal handlers, and just basically you pass in your provisioner name and an implementation of provisioner server, and it runs the gRPC service for you to some extent. That one has some tests as well. And then finally, there is deploy, which is all the stuff that you need to run. So it's let's maybe focus on the deployment itself, which then becomes a deployment in which you have the Cozy Provisioner sample container next to the object storage, the sidecar that we have. So all of this allows you to easily test this in a cluster. And I actually do this in the CI, which is based on GitHub Actions, where next to running some lints and running the unit tests and building a container, I also run some, and I call them end-to-end tests. It's not, I mean, it's somewhat of an end-to-end test where I create a kind cluster in GitHub Actions. I then deploy all the Cozy prerequisites, so the API, the CRDs, the controller, the CSI adapter, deploy the sample provisioner, wait for it to be ready, also deploy a pod in which I will then run a couple of tests, wait for that one to be ready. And then what I basically do is, because we don't implement any data plane API, is to look for what the CSI adapter brings into that pod, or is supposed to bring into that pod. Do I actually get it? Today, there's two files. There's credentials.json and protocol.conf.json. I believe that is going to change. But I copy those out of the pod, and then using some stupid bash, I check whether what is contained in those files, also calling into JQ to parse the JSON, equals what I expect to find in those files, because this is the information that my sample provisioner has returned to the sidecar. That is basically the furthest I want to go here. The CI of the provisioner sample. I don't think it should do tests of Cozy. as in, test whether when I do a bucket request and then I do a bucket access request, then a bucket exists, and then if I delete the bucket access request and things get cleaned up, maybe that would be a better end-to-end test. I didn't spend the effort to build that here because those tests, they don't only test the provisioner, of course, they would catch bugs in, say, the controller or the CSI adapter as well. So I'm not sure where those should live.
I see. I think so for the CI effort, specifically for this project, for the sample driver itself, it's going to be simpler. I mean, like just what you already have. I think we're going to have end-to-end test be a completely separate repository, which will test the overall framework, where we'll integrate all the components and then test all of Cozy.
Yeah, that makes sense.
Mm-hmm.
I try to have something here, but at the same time not test the whole universe.
Yeah. I think you got the balance right.
So yeah, that's basically it. I mean, as a storage vendor, all you got to do is, and I mean, we knew this beforehand. This is not new information. Is you implement 4 RPC calls, and well, you do so correctly. So I need to make some changes, but it's really fairly simple.
Yeah. So I have a few questions. So this makes me think. So I mean, originally we wanted this to be for 2 reasons. One is CI, and one is to be the sample. Do we or no? Not that's not what we said. So we said we're going to have this be the driver for CI alone, and we're going to We're going to have a page with all the samples shown in them, or all the vendor drivers shown in them, links to that, being the samples. So we said something like the samples would actually be Amazon's driver or Scality's driver or Google's driver, and this would just be the CI system. Is that what we decided? Help me remember, please.
I think we thought we will have like one driver that is in a Kubernetes Cozy repo. That is a sample driver, and other drivers will be vendor drivers. We can have a document, right? So we'll have a link to those drivers in that document. So this driver, I think this is the sample driver. So we actually should move that to a new repo. You're going to submit a request to create this, right?
Yeah, I am. So,
but your question was more: do we use the same driver for the sampling for a sample,
and CI,
or and for the CI, or do we have one driver for CI and one as an example?
Yeah, so my question was exactly that. So it was, do we have a separate driver only for CI, and then have the vendor drivers be the samples, or do we use this driver itself as both CI and sample?
This can be both, just like the CSI host path driver. We use that in the CI. It's also sample driver. Why do we need both?
Okay, no, that's perfect.
Yeah. That's what I was asking. So yeah, that was clear from your answer, Shing. That is, we're going to have this be both. Yeah. So Nicholas, if you can make that one change, and I'll create the repository right away, just after this meeting.
I'll make that change once the repository is there. I'll do a PR because that will be a Kubernetes, what is it, the template repository, right? I mean, a fork of the template repository. So we'll want to update the README file in there and the owners and whatever else. And then I'll do a PR from this one into the repository where this code should end up. And I can still do another code review, like, I mean, as we should, because this has been just...
Hey, I do have a question about this. I know we talked about this one last time. So this is called a provisioner. And as I was reading the cap, I thought this is actually a driver, right? So it's doing the provisioning, but it's actually the driver. I thought we still have a sidecar that's working together with the driver, isn't it?
I see where you're coming from, huh? So we're calling that the provisioner. The sidecar is the provisioner, and this is the driver.
Is the driver, right? So it's just, if you look at how CSI driver works, right? We call them drivers, and then we do have a provisioner sidecar. So, and also, what if we, in the future, we have other functionalities that is, not just provisioning, but we have some other driver functionalities.
That makes sense, actually. We can call the repository driver, cozy driver sample.
Yeah, I think that makes more sense, actually. Because I was reading that the cap was confused.
Got it. So about the cap, so that's the other thing that I want to discuss. So let's finish this conversation. So as far as the sample driver is concerned, Nicholas, I think obviously you've done a great job. Just that one minor change, and we'll have the repository, and we'll get it merged. Just make sure there are license files and all the different files that you put here. I think you've already done it, but minor boilerplate stuff like that. Just reminding.
Yeah, it's got the Kubernetes alters headings, and the license file we can get from the template that will be used for that new repository.
Right. Okay, cool. So that's one. So the second thing is about the cap. So about the cap, I think Xing and Blaine also left a few comments on it. We've addressed the comments. Jeff just had small changes to make on those comments, and we'll have it pushed within the hour or so. So Shing, we know that Elena Hashman, is that the name?
She's doing the PRR review. Yeah.
Production readiness, yes.
Yeah.
But as Friday is the deadline, and
I
Tim
think it's
hasn't.
Thursday, right? It's Friday. I thought it's Thursday. Normally it's
13th?
not a Friday.
Okay,
Yeah.
makes sense.
13th, I believe. That's
Okay,
a
yeah,
Thursday.
that is a Thursday. Yeah. So Tim hasn't gotten back to us, and we really don't want to delay it another 3 months or 4 months. It's going to be, our cadence is going to be affected if we do that.
Yeah.
Is there any chance we can get another reviewer? Tim looks like he might not respond in time, and I think
Well,
it's.
can you just suggest send another email to remind him? Because I think last week, because it's a KubeCon, I see that he was sending some tweet saying he has to get up like 3 a.m. or
I saw
something.
that.
So
Yeah, I saw that tweet.
maybe last week he was not really reviewing because of that. So this week might be back to normal schedule.
Hopefully, yeah, hopefully. So yes, I will send another email, bring it to the top of his list. And I know Saad is also trying to help from Google. But I think it might be a good idea to at least have someone in mind, so that we know who to ping.
Yeah, so at this point, I don't really have anyone. The API reviewer, I think most of our SIG storages API reviewer goes to Tim. I think sometimes I see someone else, I think it's Clayton, review some of them. But he hasn't reviewed any of mine, so I don't really know him. So I don't really have a way to say ping him, because I think at least Tim has already looked at this one last time. It's actually better. Yeah, just send him an email, since we are all like Saad, myself, are all there, right? So Saad can ping him using their internal channel, hopefully get his attention. Otherwise, he can recommend somebody else, because I was just thinking that since he has already reviewed this last time, this is a huge cap. If you get somebody else, they only have like a couple of days, right? So starting fresh with such a big cap, I feel it's actually unlikely for a new API reviewer to get it merged so quickly either. The best way is just to keep in Tim.
I see.
Yeah.
Yeah. Okay, got it. So Clayton is our backup, you're saying, and unlikely to be a good backup, you're saying, because very little time is left. But we do have one name to follow up with in worst case scenario, right?
Yeah.
Okay. All right. That sounds good. So I will send an email right away, and I'll get the cap updated within the next hour or so. And Nicholas, I'll also put in a request for the new repository. and yeah, we'll go from there.
Okay, just one question. If we change the terminology to driver, the provisioner server remains provisioner server, right? As in the gRPC interface?
Oh, so you're asking?
That thing should be fine. I think we have if you look at the CSI array, it has like a controller, have a node service, right? We have service in there as well, node service, controller service. So I think that is fine for now. I think yeah, because that's in the cap, right? Isn't it? Those terminologies in the cap?
Yeah, it's in the cap.
Yeah, so the only thing that I'm getting confused is when you're calling it a provisioner, but then I think it's actually driver. If I'm thinking about from how CSI are calling things, because that's not the sidecar. If you call that a provisioner, then what is your sidecar?
Right. Yeah, we just call it sidecar, but to be symmetric with CSI, I think it makes sense to call it driver, and yeah, and
So
like
that,
you said,
yeah.
good. It doesn't matter that much for the gRPC. Again, it's clearly mentioned in the cap. Like I think the gRPC can be called provisioner create bucket. Wasn't that your question, Nicholas?
Yeah, but then there's other things I guess we need to change as well. I don't have the spec in. Wait, let me just.
I'm saying I don't think we need to change it because we're out of time. So I'll quickly say what I wanted to say. I don't think we need to change it because the provisioner is calling create bucket. So it's like the provisioner is the one initiating this call. So I don't think that disambiguation is really going to help. But I think calling it driver.
Your sidecar will be calling this driver, right? Is that right? Similar to the okay, so that should be fine, right? So
but the identity server, we have a call called provisioner get info. So then it's the provisioner again.
I think that's a
small. Oh, I see what you're saying. Okay, see, I think in CSI it's called I think it's a driver something, driver get info. Okay. But we can probably fix those later, I think. Yeah, I just think this week's priority is to get the cap merged.
Right, and also I don't think it's going to cause any real confusion.
Yeah, but I think the repo name we need to fix it because we can't keep changing the repo name.
Yeah, that's true. Repo name we can't afford to get it wrong in the first time. Okay, so let's continue on Thursday. We're out of time. Thank you everyone, and I'll follow up on those 3 things that I just said.
Okay. Bye.
Bye.
Thank you everyone. Bye.